Hey, and welcome to this talk. Just before we get started, I want to say a huge thanks to the organizers of NI DevConf for putting on this remote conference. So first, who am I? I'm Chris Laughlin. I'm a JavaScript engineer in Rapid7. I build web applications that secure web applications. Yes, that is very meta. I've updated a README to an open source file before, so now I'm an open source contributor. I've streamed a few times to Twitch, so now I'm a Twitch streamer. And I also have created a few SitePoint articles, so now I'm obviously a SitePoint author. I like to think of myself as a jack of all trades, master of none. So today I'm going to be talking about micro frontends and if they are the future of web application development. But first I want to take a little for some people a trip down memory lane, for others a bit of a history lesson on where we came from and where we've got to with web application development. So in the beginning, we had server render pages using technologies such as JSP, ASP, and other different tools. I think you can even use PHP at this point. And the core principle is having a server rendered page. So you'll have a server that will take a template, usually a kind of like HTML file that will pull in your data, render out your HTML, your CSS, and in some cases add in a little bit of JavaScript to the mix. Very performant, very efficient, well structured, and easy to understand. And I managed to dig back in the old archives and find some really old examples. As you can see, we've definitely come a lot further on the web than we have. So what are the kind of core benefits to a server render page? So one of the kind of main things is that it's all single pages. In some cases you could have just one page, but you separate out your logic, your business understanding, your domain level knowledge into different pages. So you'll have an index template, that's your home page. You'll have an about template, that's the kind of details of your company, your site. You'll maybe have a contacts template that'll have like a form and all these kind of different logic in it. So each of them is separated out into different areas of your domain level knowledge. Easy to understand, easy to manage. Also, it kind of brings all your technologies together, so you have your HTML, your CSS, your JavaScript all in one location, so you're not having to go around trying to find where you made changes or where the code needs to be. And kind of lastly, and it goes in the kind of the name of it, they're server rendered, so they're efficient. So you're fetching all your information, rendering out the entire page, and then sending that down the line to the user. This is great for things like SEO, because you can build out all your keywords and your meta tags as and when you need them, and it's all given to the user and given to those search engine optimization tools immediately. This makes for a really good performant way of sending data down the pipe to your user. Obviously, where there's benefits, there's got to be problems. So kind of one of the upsides, but one of the downsides is the server-side limitations. So at the time of generating the page in the server, you might not have all the information you need for the user, or in many cases you're bringing back more information than the user needs. Take the example of an order status page that maybe will fetch all the orders, fetch all the statuses for all the orders, where the user might only be looking for the status of one order. This is a unperformant way of doing it because you're fetching all that data over and over again for every user. Or whenever you're moving from page to page, it's loading a brand new page each time, so you're making those calls to get all that user data, all that product data, where necessarily it's not needed every time. And in many cases then this leads to people adding hydration at runtime. So hydration is just the concept of having a server render page that renders out the bare bones of what's needed for the user. Then at runtime, we'll inject in a JavaScript framework, which then will start rendering out more of the page, fetching more of the data, and providing extra functionality on top. This is always kind of needed because you're limited to what you can do in the server and the interactions that you can handle and process. And this kind of leads into the next part where these sites become really hard to scale. Because you have a lot of logic potentially duplicated over multiple pages, making a small change can be really tricky to verify and test. Having multiple teams working on maybe one file at a time is really hard to track. With merge conflictions and cross wires, it's easy to generate and push out bugs to your users. So this kind of results with like a small little fire that it's a bit hot, but we can deal with it. But then the world advanced. So then we move on to the world of single page applications. So the kind of core concept of single page application, in the name, is it's a single page. So you'll have one templated file that gets sent on to the user. You'll have a JavaScript framework then that kicks in. It then handles the additional rendering of the different templated views. So you'll have a client-side router, you'll have different client-side pages, all hosted off the one server-served page. You'll have the framework then that's going off and fetching your data and doing all the interactions that the user needs. So the core benefits for this is it's fast and responsive. You're not waiting for the full page to generate on the server. You're sending down more or less like an empty template file. Then the JavaScript framework kicks in and handles the rest of it. So it's fast and responsive. You can potentially load up parts of the site as the user's interacting with it. As well as this, you're not fetching off all the data that you need to do. So this kind of leads into our caching benefit. It's easier to cache your resources and cache your information. You're maybe only using one JavaScript file and one CSS file in this case. And because you're fetching the data as and when the user needs it, you don't have these unnecessary calls off. So take our example of our order page. Now we'll only fetch and load back the order that the user needs. If they then progress through the site, we can load and fetch other orders. So we're not having to fetch additional information that they don't need. This kind of leads into then a faster development and debugging. Development wise, we can have different developers working on different components, different files. We can break our application up into logical sections. So we'll have a components folder, we'll have a pages folder, we'll have a modules folder. And this is different areas and different features that people can work on. So it reduces confliction, allows people to quickly progress. And because it's all handled by the browser, we can easily develop or debug with the browser tools that we have. So it's harder to debug a site that fails for a customer when it's been loaded on the server. Whereas now we could potentially jump on a call and debug with the customer live using the browser's development tools. So it gives us that easier to check, easier to test approach. And again, where there's benefits, there's problems. So first one, the kind of biggest one is say goodbye to your SEO. Because everything's loaded by the browser and generated by the browser, it's harder to generate SEO rankings. With the server render page, everything was built up and rendered before the requesting browser got the value. In many cases, the Google SEO tools will fetch the page, try and wait for a little bit of JavaScript to run, but in many cases it doesn't do a lot. So you're losing out on a lot of your SEO optimizations. Then this kind of leads into, because it's all being done by the browser and by the client, this pushes a lot of the process into the browser. In our server example, we can control the memory of our server, the CPU of it, and how it scales and grows. Now we're dealing and telling the customer that they have to do that processing. So we're dependent on the browser that they use. In many cases, this forces customers to move on to a modern browser such as the latest version of Chrome or Firefox, and kind of pushes them away from older versions of IE. Not that they shouldn't be still using IE anyway, but in a lot of cases, some customers are constricted to an older version of IE because of some sort of internal compliance rules. So we potentially lose users out of this equation. And this then as well can be hard to scale multiple teams. So we now have multiple teams working across multiple different files, trying to add and remove components. Because it's all done at runtime and built by the browser, again, it's harder to test because we struggle to verify what goes in and what comes out. With the server one, it's easy to just kind of hit the server, test the page. Now we're having to go through, interact with the application to get all the different user scenarios that we're required to use. But then the world advanced again. So then we were given different tools that make single page applications great. So we get tools like Webpack Parcel and all these other different bundling tools that allow us to take a single web application, bundle up, and deliver to the user in the most efficient way we possibly can. So what are the key benefits of this new approach? So we get this idea of a bundled distribution. So bundled distributions is just a way that we can package up our web application and send it down the pipe to the user. In many cases, this will involve optimizations where we can do dead code elimination, we can minify our code, we can make code-splitted bundles. So it's not just one bundle going to the user. We could potentially send down multiple that are lazily loaded at runtime. And then this kind of leads into improved caching. So now we have the ability to say cache like our vendored files. So the libraries that we use that we know never change. Cache our styles, our images. As well as this, we have the added benefit of doing these code-splitted approaches where we can go off and only fetch parts of the application whenever the user is using it. So it's all kind of bundled up and managed in that way. Then this kind of leads into the ability of having mixed rendering. So kind of pushing back to our old server approach where we would load a page in the server and then send it down and do some hydration on the client. We can now do that with these modern frameworks. So we can get the server to render out our bare bones site with our most optimal SEO in place. So we've got our SEO back. And then we can hydrate with our normal JavaScript frameworks, let them take over from there and have that smooth user experience. Again, where there's benefits, there are problems. So now we have to deal with framework complexity. So do we use Webpack? Do we use Parcel? Do we use React, Angular, Vue, Svelte? There's too many to choose. Each of them have their own benefits and also their own problems. So you have to have a balance of what is it you're trying to build and what can they provide for you. This kind of then leads down to the world of bundle chasing. So everyone wants to have the most optimal small bundled JavaScript to send down the user. But trying to manage that with different frameworks and different tools can be tricky. Prime example could be you're using the debounce function from Lodash. You import that in, but you're actually sending the entire Lodash library down to your user, even though they're not making use of it. So it's how do we manage, how do we get those proper dead code elimination, code splitting approaches to make sure that we're not actually increasing our bundle by using tools to make it smaller. And again, we can kind of see a trend here. This is hard to scale when we have different technologies to bundle up our application, do different after effects to the code before we send it to the user. How do we get that to grow? How do we get multiple teams to work on this? If everyone's still working on this one big repository with all these different files, there can be conflicts, there can be clashes, and trying to fix and push those out. Then how do we test and verify that we haven't broken any additional features? So now our small fire is in the raging blaze, and we need to get out of the building because it's going to go. But this is fine. Modern JavaScript comes to save us again. This is where Micro Frontends come into play. So Micro Frontends is kind of similar to what you think of as like a microservice architecture for a backend application, but applying the same principles to front end. So we can see an example here. So taking those kind of projects that we've been talking about before, where you have either the one big server rendered page or a single page application that's made up of multiple different folders for like components and different pages in different areas of your application. Let's break this down into a bunch of different applications, and these become their own repositories, their own teams. They all have their own backend, their own database, but they share code and they share information across each other. So in this example, we have our Inspire team, our search team, our product team, our checkout team. Each of these is a mission critical feature in the application, and so should be treated with importance and allow them to be able to advance and grow independent of other features. The checkout team shouldn't have to care and worry about what the search team are doing, and vice versa. They should be able to ensure that the checkout process does its initial and correct checks when you're purchasing a product, or it's handling how we display what products are in your basket as best as possible. The search team should be involved in optimizing how they're searching the data, what query language you're using to check all this, and they don't have to care about the checkout. They should be advancing, pushing forward. And it's letting these different teams grow without breaking the entire product. The kind of core idea with Micro Frontends is kind of leaning towards a little bit of what code splitting was, where you would break your application into smaller bundles, and on demand, as the user interacts with your application, load in those parts of the application. Prime example is if a customer comes and all they ever do is search for products, they don't need the checkout code because they're never going to interact with it. It's only until they come to the process where they click, buying an item. Then we go off, we load all that complicated, heavy code for the checkout, and the user can continue on with their flow. So how do we manage and build out that experience is really important. And a talk won't be a talk without a demo. So let's take a look at this in the real world. So I've got a little GIF here of the application running. It's an alcohol store because, Northern Ireland. So in this example, we've clicked to buy. We're now actually making a request, and the network's slowed down for this example, but we're making a request over the network to get the code for our basket component. The basket component is now rendered. We're able to interact with it. And if we clear it and click buy again, we're not actually refetching that information. So this brings in a lot of our different kind of benefits of we're able to cache our resources. We're able to load them on the fly. So we're not pulling back huge resources. So if it was a server example, we'd always be bringing back the basket code. Because this is all done over the network, we're able to give the latest and greatest of the code. So in this example, our basket team can be advancing, pushing forward, and our home team, which is the kind of host container of our application, never need to know what's going on or if they need to update to get a new version of the basket. Whenever the user uses the application, they're always going to get the latest and greatest version of the application. So this is kind of an example of how we can do a micro frontend approach with a small application. But what does this look like in practice? So let's start off with our basket. So this is all done via Webpack, and it's in the beta version of Webpack 5, where we have this idea of Module Federation. So now we have this Module Federation plugin that we can use in our Webpack config. So we have to configure it with some values. So we give it a name. This is just a way of naming it so we can understand what it is. We define the library type. So in this case, var, because it's code. This could be JSON, SVG, image, CSS, whatever we want. It can be just a resource because it's asynchronously loading and managing this resource at runtime for us. Then we give it a file name. So in this case, remote entry. So this file name is going to be the file that lives on the server or the CDN or wherever you're hosting your application. And it'll be pulled down at runtime by your code. Then we say what it exposes. So it can expose multiple things from the one module. So it's not just a one component per module system. In this case, we're saying it exposes a basket component, and then we point to the source where the basket component lives. So source/basket. And this is where it kind of gets a bit more interesting as well. So we have this idea of shared. So these are shared dependencies across our module federated application. This allows us to share resources. So for example, if our basket component uses React and our host component uses React, we don't want to be pulling in React twice, mainly because it won't get used twice. You can only have one version of React running on the page at the moment. But in cases where, say, the basket is using Lambda to do some computational functional programming, our host component isn't because it's just a bare bones container. It doesn't need to have Lambda as like an npm module installed, or we don't have to set up basket has it as a peer dependency. At runtime, Webpack will pull in the basket, see that the basket depends on Lambda, look at our host application, see that it doesn't have it, and then say, okay, basket, give me your version of Lambda. So the basket will also expose out its shared modules. And this allows us for very optimized code sharing, and especially dependency sharing across our application. So we've created a module plugin, exposed our basket. Let's jump over to our home component. So very similar home component, we pull in our module federated plugin, we give it a name, we give it a type, and this is where it gets interesting, where whenever you do a module federation plugin, it's not always a case of either you're exporting or you're consuming. You can do both in the one sitting. So in our example on basket could be a fully fledged application, but it also exports out a bit of shareable code for anyone else who needs it. And the same for home. Home is consuming, but it could be sharing out its own additional code as well. So you can do multiple layers of this approach. So again, give it a name, give it a library, and this is where it's different then. We say remotes. So we give the remote a name, and this becomes like our like fake npm module name. And in this case, we're just using mf as a Module Federation kind of shorthand. So mf basket, that maps to the basket. And then again, we declare a shared dependency. So if this was being consumed, it'll be able to share its dependencies too. So how does this look in our actual application? So in this case, I'm using React for example, but this is available in Angular or vanilla raw JavaScript. So we check this out. So normally we would do import basket from and then basket because it's an npm module. But in this case now we're doing a lazy render. So we're creating a const of basket using React's lazy rendering function, and we pass it our import. So now the module name is mf_basket/basket. And the reason it's /basket is because our basket module can export more than one thing. So we have the ability to export out different components. So you could potentially have a module federated shared component library where each there will be the one component and exports out all of your different like modular components, like a card, tabs, wizard, that kind of thing. So yeah, so once we've defined how we're importing our component, we then go to use it, and we use it like we would any other React component. The only difference here is we wrap it in a React suspense component. So because the basket code is actually being like fetched at runtime over the network, we need to be able to handle the fact that basket doesn't exist until it's loaded. This is where React suspense will wrap a component and say, okay, my child needs to be asynchronously loaded, so I'm going to show a view until that happens. And this is where our fallback prop comes into place. So you can say in our case we're just passing in a div with loading basket. This could be anything we want. It could be another component, could be just raw HTML. And once that's completed, it's going to render in the basket component to our tree, and then we interact with it just like we would any other component. We can pass it props, we can pass it callbacks. It just works like it was bundled as part of my internal source. But what happens in the case where the team who are working on our basket component forget to restart the server whenever they're deploying, so the server's down, or they deploy a break and change that triggers an error that we haven't accounted for? We don't want to break our application. This is critical core functionality. This is where we can put in our own fallbacks. So I know React Suspense has a fallback, but this is kind of a fallback for an error. So the approach that I like to think about is you want to use Module Federation to get the latest and greatest version of your components or your code or whatever utilities, whatever you're importing in for it. But you also want to be able to handle if things go wrong. So the basket team do two things. They build and deploy like a npm module version of their code, but they also push the Module Federation version up into like a CDN where we can access it. So they have a latest stable version, and they have their latest, blazing fast version that we can get anytime we want, but that's prone to breaking. So in here, we're going to create a basket fallback, and again use React Lazy to import in the npm installed module version of it. So this is our always stable, always reliable version. It may be a little bit behind in the changes, but we know it'll work, and we always have that mission critical flow in our user flow. So then we can say if we're using a React error boundary kind of approach, we can catch if there was an error. So this would be if the rendering of our basket here broke because either the network failed or the actual basket itself had some breaking code that threw an error that we couldn't handle. So we'll catch that error, and then we wrap it in the suspense wrapper again with another fallback, and then we have our basket fallback component. As normal, use it, pass it props, pass it callbacks, do everything that we do with a normal React component. The reason this is wrapped in suspense as well is the fact that we only want to load our basket fallback whenever our basket fails the load for us. So we don't want to be always shipping down the fallback version. So we want to asynchronously fetch that too. So it gives us another optimization layer where we're not shipping the default, even though 9 out of 10 times you're going to get the new version of it. We optimistically check which version we need and how to get it. Okay, but you're probably asking yourself, but why? Why is this important? Why do we want to do this over the network micro frontends approach? I think the key approach here is how we build and structure and get our code. Prime example, if we go back to our application where we have a basket team and a search team. If the search team is trying to really advance on a feature quickly and ship and build really fast, potentially under a beta flag or something that it's not as important to users, but they need to get it into users' hands for testing. If we go for an old approach of old micro frontends that a lot of people use now, where you have multiple NPM modules, you make a change to that, publish it to NPM, your host application pulls that in, does a rebuild, and then deploys that out. That can be really slow, and it can be hard to get things moving quickly. If you're working with 5 different micro frontend projects and then pushing into the one host, you're potentially deploying that host 10 to 100 times a day. Whereas with this module federated approach, you're always loading the latest and greatest over the network. So no matter what, your users are getting what you need them to get as soon as possible. And then having this fallback approach, where if it does go wrong, you go back to the latest stable version of that component. It means you're never degrading the experience for the user, you're never breaking what they need to do. All your mission critical stuff will still work, it just might not be as flashy and shiny and fast as the version that could come over the network would be. Okay, but this sounds too good to be true, and in some cases, actually it always is. So a couple of the kind of problems here. As we said before, where there's benefits, there's obviously problems. One of the main ones here is complexity. We've now kind of breaking that pattern of having multiple NPM modules merged into one component or host application and then deploying that out. That's very easy to understand. You know what version everything is. You know what the code looks like. It's all, because it's all bundled, you can inspect and you can run checks on that code. Now we're loading code over the network that we don't know what it does or where it came from. So there's issues when it comes to what if the search team is pushing out malicious code and they don't realize it? You can't verify what you push out is correct. There's measures you can put in place, like context security policies and that kind of thing, to help alleviate that. But it adds a layer of complexity. You don't always really know what is running in your production application. And with this, there's a potential for bundle increase. So we've been kind of pushing for this idea of most optimal code that we can push down to the user to have minimal renders, first meaningful paint, all that kind of thing. But say, prime example, the search team is using Lodash to do all their functional programming. The basket team is using Ramda to do all their functional programming. 2 JavaScript libraries to do similar things, but now we're shipping both of those down to the user. Whereas if we could connect together and use the one library, it means we would be using less and sending less down the pipe to the user. That kind of leads into the potential for rogue teams that are going to go off, not follow standards, do their own thing, break the kind of unity of the product. And this is where communication and organization has to be key in a micro front-end approach. So everyone is on the same page and working off the same tune to make sure that they're not pushing out things that are going to be detrimental to the user, but beneficial just for their one part of the application. And kind of lastly, maturity. As with all JavaScript frameworks that are kind of new and hip and cool, there's a level of immaturity to them. It hasn't been battle tested. There isn't set standards. There isn't ways that we should definitely do this in the wild. But getting in at the early level allows you to be able to either set those rules or follow on quickly and change your code to match those rules as you go. Going from a monolithic architecture to a micro frontends architecture is going to be harder than going from a micro frontends architecture to a monolith whenever you realize it doesn't work for you. So should you adopt micro frontends? Yes, but with a small y. It's not mature enough yet. A lot of it's in beta. People are writing their own solution for this all the time. Get in early, don't do it on something mission critical, and try and learn and experience that way. And thank you for listening.